Potential and Kinetic Energy, page 31. This is the only paper you really need. Cut off the border and cut out every box. Alright. The two concepts we're going to discuss are gravitational potential energy and kinetic energy, both of which concepts I've already introduced and discussed in energy types and transformations on page 30. So, basically what I'm going to do with this is we're going to get into more detail and get into their calculations. Each one of these has a formula. So, we're going to start first with gravitational potential energy. So, if you look back your notes on page 30, you could fill in that blank. Gravitational potential energy is the energy of, the nice fancy formal definition, alright? It is called the energy of position. So the energy something has based upon its location or where it's positioned. Well, that seems kind of vague. So I kind of prefer to call it the energy because of gravity. So we're talking about that awkward feeling you have when you see on a shelf above you, high up on the shelf, a bowling ball. Just sitting there, ready at any moment to fall down and go splat on your head. Okay? That feeling is a very sad feeling. It makes you very uncomfortable to look up and see that staring at you. Wants to come down and go splat on you. It's not doing it, but it has the potential to go splat on your head and be very miserable. Okay? So, potential energy due to position, due to gravity. Okay? Now, often in physics books, they just call this potential energy. But we know, as we discussed in page 30, that potential energy is a whole category with 4 different options. And that gravitational potential energy is just one of them. So, gravitational potential energy often is just called potential energy. Hence the title, Potential and Kinetic Energy. Now, the formula for this is right here. PE equals mgh. So go ahead and make sure you space above and below the formula to fill in a few little notes. Okay. So potential energy. That's what the PE stands for. Potential energy. Okay? But we actually know this is gravitational potential energy. Okay? M, we should all know what that stands for. Mass. G stands for gravity. And H stands for height. Now, remember gravity, that's the negative 9.81 meters per second squared. All right, that's the acceleration due to gravity. Okay, in this case, we're going to keep it positive for most of these numbers. Okay, and that is an acceleration. Okay, so mass, gravity, and height. Now, units of measure. What are the units of measure for energy, regardless of whether it's potential energy or kinetic energy or electrical, or what are the units for energy? Well, that's joules. Units for mass, kilograms. Units for gravity, meters per second squared, that's that acceleration. And units for height are meters. Now, it may be necessary to rearrange this formula. We will never solve for gravity because we already know what gravity is. But we might solve for the potential energy, the mass, or the height of an object. Now, you may look at this formula and go, well, I can't put that in the triangle. Well, actually, you can, if you're very careful. So, we could put this in the triangle in 2 different ways. Okay? The one hint, you can either look at it as mass and gravity multiplied by height, or gravity and height multiplied by mass. Either way, potential energy is always going to be on top in the formula. So mass and gravity multiplied by height. And we could use that setup to solve for the height. Height is equal to potential energy over mass times gravity. Or, like I said before, we can look at this as gravity and height multiplied by mass. So potential energy is equal to the mass multiplied by gravity times height. In which case, we use that to solve for the mass. Mass is equal to potential energy divided by gravity times height. Now, it is very important in this that you are careful to multiply that denominator, or put it in parentheses. So you multiply that before you do any dividing, so you don't get order of operations incorrect in your calculator. So that's your formula for gravitational potential energy. All right? In order for gravitational potential energy, remember the key things: how big it is and how high it is. So if you think of a couple different options, let's again go back to our shelves. Okay? We have a set of shelves here. If we put a bowling ball on the top shelf, or a bowling ball on the bottom shelf, and you have to stand right here, and one of them is going to have to land on your foot, which one is going to have less potential to crush your poor little toes? Well, the one with the lower height. They have the same mass, but he has less height, so he has less potential to crush your toes. Now, let's look at that a different way. Let's talk about mass. Let's put a marble on the second shelf and again, let's just stick with a bowling ball next to that marble. One or the other has to fall and hit your foot. Which one do you want to hit? Which one would you rather hit your foot? Which one has less potential to squash you? Well, the marble. They're at the same height, but it has less mass. So that's a good way to think about it. What has the most potential to squash if its energy was released? Okay. So that's gravitational potential energy. Now let's move on to kinetic energy. All right, so this is the general kinetic energy. All right, so kinetic energy is the energy of motion. So there's your key thing. It must be in motion. It must be moving. If an object is moving, the object has velocity. Okay, so here we go. Here's your formula. Kinetic energy is equal to 1/2 mass velocity squared. Go ahead and take that. Glue it in. Make sure you leave a line, at least a line above, a couple lines above it, space below it. All right, KE, that stands for kinetic energy. Okay, the 1/2 is just part of the formula. M is mass, and V is velocity. Again, the squared is just part of the formula. Just don't forget to square the velocity. Very important step. Many people forget. All right, so kinetic energy, energy measured in joules. The 1/2, when you go to put that in the calculator, here's a helpful little hint. Just put in 0.5. It's a lot easier. Mass That's going to be measured in kilograms. And velocity, units of measure, meters per second. Now, a little note on this. Mass and velocity. Okay? How big it is and how fast it's going. Those are the two factors that determine how much kinetic energy it has. So, if I take a ping pong ball that's going 2 miles an hour, or I take a bowling ball that's going the same 2 miles an hour, which one's gonna hurt more when it hits? Which one has more energy in it? Well, the bowling ball, because it has more mass, even though the velocity is the same. Similarly, if I have a baseball, all right, and I throw it my pathetic little maybe 10-mile-an-hour pitch, and it hits you in the arm, you're like, ow. But that's about all you're going to say. However, if I have a professional baseball pitcher throw that ball, fastball, at 100 miles an hour, super fast, right at you, it could break your arm. Okay, it has more kinetic energy because it has more velocity, even though the masses are the same. Okay, so that's the essence of kinetic energy. Remember, for us to use this formula, the mass has to be big enough that it's actually worth measuring. Same thing with the velocity. Okay, so we have to have a mass that's big enough to measure. When we're talking about other things like electrons, that electricity, it's just too small to measure an electron. So the mass of it. So we have other ways of measuring the other types of kinetic energy, which include the electrical, the thermal, the radiant, and sound. There's better ways to measure those than using this formula. This formula is for objects that are tangible, that are big enough that we can actually measure its mass on a reasonable scale. Okay. Now for this formula, rearranging for mass and velocity. This is a slightly scarier deal. Okay? So I'm actually going to do this on the OOPS page. So just pulling it right over, not even going to the top of the page, just right over here to the side. Let's take the formula. Kinetic energy is equal to 1/2 mass velocity squared. Okay? And let's say that we want to find out what the mass is equal to. What if the mass is our question? We need to rearrange that formula. Well, I want to get the 1/2 to the other side of the formula. So back to basic algebra skills. If I want to get 1/2 to one side, then I actually multiply by 2. Okay, so I'm going to multiply this whole thing by 2 and multiply this by 2. That actually cancels out the 1/2. Okay, so I end up with 2 times the kinetic energy is equal to the mass times the velocity squared. Well, I still want mass by itself, so I need to get the velocity squared to the other side. Well, it's multiplied, so we got to divide that. So divide by velocity squared. What you do to one side, you got to do to the other. And now those velocities cancel out. Velocity squareds cancel out. So you end up with 2 times the kinetic energy divided by the velocity squared is equal to the mass. This is how you solve for mass. When mass is the question, that's the formula you use. Okay? Now, if you hate algebra, like I did when I was in high school, this is going to be something you're going to want to refer to when you need it. All right. Similarly, start with the original formula again for kinetic energy. 1/2 mass velocity squared. What if velocity is the question? Well, then we have to rearrange that formula to solve for velocity. Similarly, we're going to start with the same step. We're going to get the 1/2 to the other side. So I need to multiply the whole thing by 2. And what I do to one side, I got to do the other. That 2 and 1/2 cancel each other out. Okay? So now I have 2 times the kinetic energy is equal to the mass times the velocity squared. Well, mass and velocity are multiplied. We want to get the mass to the other side, so we're going to divide by mass. What I do to one side, do to the other, divide by mass. Those are going to cancel. All right, so now I'm left with 2 times the kinetic energy divided by the mass is equal to the velocity squared. we still need velocity by itself. It's not by itself yet. That squared is still there. We need it by itself. So we have to do the opposite of squaring. Well, the opposite of squaring is a square root. So we have to square root v squared. What I do to one side, I must do to the other. So that square root and that squared cancel each other out. So we are left with v is equal to the square root of 2 times the kinetic energy divided by the mass. That is the rearrangement of the formula to solve for velocity, if velocity is the question. Okay? These two will be provided for you on the quiz. All right? Along with these arrangements as well. But I just want you to see how I got to those numbers. Okay? To those formulas. So that's potential and kinetic energy basic introduction.